I want to give you some extra information. What are those? No. One. Metals like aluminum, iron, cobalt, nickel, etc. are rendered passive. Means initially they react, after they stop reacting. Okay. So this is called this. Rendered passive by concentrated ANO. It is probably because of the surface oxidation. Initially they get oxidized, and after that they do not react. So that is they form a thin layer of oxide on the surface and sticks to it. Sticks to the and sticks to the metal by which metal further do not react. So this is called passive. This passivity, so you know that you find that every now and then the same thing is being told to you at home. But initially you used to respond. After that, you thought that they will speak, I will not do. This is all. Nitric acid does not liberate hydrogen from metals. So nitric acid is never used for generation of hydrogen. Now exception is that only magnesium and manganese react with very dilute. See, you will not imagine what is the concentration. 1%. HNO3 to produce hydrogen. This is important for your entrance exam. We can write now here magnesium HNO3 1%. lithium nitrate and hydrogen. Please remember for your interest. Okay.
Answer.
Now we'll do one important question is that you do in your laboratory. This is called brown ring test. This test is performed to identify the presence of nitrate ion in a salt. The salt solution of a nitrate salt, let us write here MnO2 is initially treated with dilute H2SO4 followed by the addition of a saturated solution of ferrous sulfate and concentrated H2SO4. Then concentrated H2SO4 is added gradually along the inner wall of test tube. A brown ring appears at the junction. This will your teacher will show you how to do it in the laboratory. So I try to draw it. This is the solution of metal nitrate. To that what you add? Dilute acetic. What is the next step? Next step we add saturated solution of ferrous sulfate. After that, what we do? We fill the test tube like this. Solution will like this, and here along with this wall, we add here concentrated H2O. Slowly gradual. Then what we get here? See here. This is the solution. Here you are going to get a brown. So I'll now do the reaction. See, when you add here metal nitrate, to that you add here dilute sulfuric acid. What does it give you? It gives you metal sulfate and 2 molecules of nitric acid. Mind it, this is because it is water. We write down here aqueous. So you get here now dilute. You get dilute solution of nitric acid. Okay. Then you have added here ferrous sulfate. And here you have added nitric acid, dilute. So now you know it very well. Dilute nitric acid gives you what? Nitric oxide. So it will give you ferric sulfate. This will be oxidized, ferrous will be oxidized to ferric sulfate. Ferrous sulfate, and here you will get ferric. I'm not balancing this one. You get water and you get a nitric oxide. See, we have taken saturated solution. So you have lot of ferrous sulfate is there in the solution. What is going to happen now? See, this one is going to form complex.
Excuse me, sir. What did you wrote after H2O?
This one?
Yes.
NO, nitric oxide, NO.
Okay, sir. Thank you.
Ferrous sulfate, water, and this nitric oxide is going to form a complex. Okay. This is the brown ring. The name of this complex is penta aqua. Water is called aqua. Nitrosyl iron to after the gap. This is important for your exam.
Done, sir.
Okay. So now with this I finish nitrogen. I'll go to phosphorus. See, phosphorus is an element which you cannot get incrusted in the nature because it is highly reactive. Sometimes because by the biological degradation of the remains of the agriculture waste, sometimes phosphorus is generated, but moment it is generated, it comes in contact with the oxygen of the air and catches fire. So you'll never get. Okay. But phosphorus we get it in the combined state. We have lot of phosphate ores. Phosphate ores are there. Okay, these are called apatite. Not appetite, apatite. APATIT. And but the major source of phosphorus is our bone. See, thousands and thousands of animals die. From the carcasses, the people may take out their skin for leather, but the bones are left like that. So these bones are being taken clean. We remove all the bone marrow from there, all organic impurities are being removed, and after that the bones are heated and crushed into powder. Okay, that is called bone mash. Sorry, not bone mash. We crushed it into powder. Okay, and from that, this is called bone meal. Okay, so this I know you know that this is also being used as a fertilizer, especially for growing of flowers. Okay, and this is extraction of phosphorus is not in your syllabus. Still, I'm telling you. So So this bone meal is taken and mixed with sand and coke and is being heated in a closed chamber. Okay. We heat it very strongly. So it gives you calcium silicate and you get here P4O10. We don't allow the air to go inside. Okay, we heat it and the coke which you have taken, it reduces the white phosphorus pentoxide into this carbon monoxide. The phosphorus vapor which comes is highly toxic, is being immediately cooled, and you get white or yellow phosphorus, which is always being kept immersed under water. Because white phosphorus, moment you take it out, it will catch fire with oxygen. So this is the extraction of copper from bone meal. You should know where from you get. Now we can come to the allotropes of phosphorus. Allotropes means same element existing in different form. Now you have here white or yellow is not that strong yellow, it is pale yellow. So in your book is given white phosphorus. We also call it white phosphorus, but in some of the book is given yellow phosphorus. So for that you should not get confused. Second one is called red phosphorus. Then you have here black phosphorus. Okay. Now we go for white phosphorus. You can read from the book or from my note also. Then this note I'll send it little later, because I'm taking the class now and I forgot to scan it. In fact, just scan. I think somehow it got misplaced. Anyway, the white phosphorus. See, this white phosphorus is found to be extremely reactive, and as I told you, sometimes it exists in yellow form also. So it consists of four phosphorus atoms placed at the vertices of a tetrahedron. That is, it looks like this. I told you already, phosphorus cannot form triple bond like nitrogen because of their large size, and they cannot form pi. So this is the one. Okay. See here, the bond angle is 60. It has a bond angle of 60 degree. So 60-degree bond angle is highly strained and is highly strained and most reactive in nature. Moment it comes in contact with air, catches fire. See, the name has been derived from there only, because in dark, if it catches, daytime you may not be able to see its flame. Night it catches, you will find flame is available. Is visible. And the name phosphorus has come from the word phosphor. Phosphor means which glows. Okay. So what happens now? See here, it will come in contact with the oxygen and it will form this. So from there, the fire is there. Okay. It is insoluble in water. But soluble in carbon dioxide. It is very toxic. So from what question you can expect? This is the one. Why white phosphorus is highly reactive? So you write that white phosphorus, where four phosphorus atoms are being placed at the vertices or the corners of a regular tetrahedron and have a bond angle of 60 degree. This imparts a lot of strain in the molecule, because of which it reacts immediately. Now we'll red phosphorus. Red or scarlet phosphorus. That all of you have seen, it is there in your house and you are using it. Eh? Red or scarlet phosphorus. With this we made matchbox. Whenever it undergoes friction, it catches fire. Matchbox. Side of the matchbox is also having red or scarlet phosphorus. Okay, but it is not as reactive as the white phosphorus. Okay, it is prepared by heating white phosphorus in a closed chamber in presence of inert atmosphere of argon at 530 Kelvin for several days. Okay, so by which you will get it. So is white phosphorus Phi-113 several days in presence of argon. So you get down here red or scarlet. Okay. It is non-toxic, not soluble in carbon disulfide. What will be its structure? It does not react with air at ordinary temperature and burn. Doesn't burn. Otherwise, it would not have been used in a matchbox. Okay. So how does its structure looks like? Okay. So its structure is like this. See here. In this case, it is not being connected to this side. No, sorry. It is like this. Yeah, it is there. So many units like this are being connected like this. So it is a polymeric bond.
Done, sir.
Then comes the black phosphorus. You read from the book. Black phosphorus is prepared by heating white phosphorus at 473 Kelvin under lot of pressure. And white phosphorus is not having a three-dimensional geometry, it is having a two-dimensional geometry. Okay. So now we'll go to the compound of phosphorus. Phosphine. Okay. Preparation. Each from metal phosphates. That I told you the formula also. When metal phosphides are treated with water form so say you have taken calcium phosphide to that if we add water. You have seen from calcium nitride we can prepare ammonia, and from calcium phosphide it gives you phosphate. It will give you see this is also being applied in war. Suppose say a soldier is being surrounded from all sides by enemy, it has no other way to escape. So they prepare smoke screen. So they burst these phosphide shells. When they burst the phosphide shells, then phosphide comes in contact with the moisture of the nearby and immediately forms a very dense what should I say, smoke. So nobody will be are able to understand where they are. And with this technique, they can go away from that place. Okay. Second, laboratory preparation. In laboratory, it is prepared by heating white phosphorus in a concentrated solution of sodium hydroxide in in a atmosphere, sorry, forget, in presence of carbon dioxide, because white phosphorus should not come in contact with the oxygen. So we put, okay, right, in an atmosphere, in an atmosphere of carbon dioxide. So we write now here P4, the sodium hydroxide, 3 molecules of water. Here I write carbon dioxide. So it is going to form CnAH2PO2 plus pH3. This is called sodium hypophosphite, and this is the one that you get. It is a gas.
Done, sir.
Okay. So let us write that is property. Physical. It is a colorless, highly toxic gas with an odor of rotten. It is sparingly soluble in water. Why? Because it cannot form from this question. It is because of the of less electronegativity of phosphorus atom, the pH bonds are less polar and cannot form intermolecular hydrogen bonding with water. So this. So you need not write so much. If you just why it is sparingly soluble, you will simply write the phosphine cannot form effective hydrogen bonding with water molecule. Finish. I have given the explanation. Okay. Now B. Chemical property. Okay. Basic phosphine. See here. Is a weak Lewis. No, I'll write there. Not write. Phosphine is a loose base. But it is much weaker than ammonia due to the larger size of phosphorus. However, it reacts with acids to form. See, ammonia, when it reacts with acids, it forms ammonium salt. Phosphine will react with acids to form phosphonium salts. Form phosphonium. So let me write example PH3 plus HI. It forms phosphonium iodide. Phosphonium iodide. No, this is for your entrance exam. Pure sample of phosphine can be obtained by the reaction of PH4I with base. So PH4I plus NaOH will give you sodium iodide H2O and then next one is your book is given. Reaction with copper sulfate and mercury chloride. We have found that copper sulfate, please don't write. When copper sulfate reacts with ammonia, it forms a complex. We call it tetramine copper sulfate. It is deep blue in color. But when you react copper sulfate with phosphine, it does not form any complex. Okay? It forms a very strange thing. See. You get now here copper phosphide, very strange. Doesn't form any complex. So similarly, when you have taken mercury chloride and you react with phosphine, it gives you Ag3P2 6HCl. So you get now here mercuric
Done, sir.
Okay. Now oxides of phosphorus, which is not in your syllabus, but I'll just draw the structure because for your entrance exam. So that now here oxides of phosphorus. Phosphorus form two types of oxides. One, phosphorus trioxide. Okay, actually its formula should have been P2O3, but this structure is not stable. Okay, so if two of the unit get joined together, its formula is P4O6. So don't get nervous. And second one is phosphorus pentoxide. P4, it should have been P2O5, but two of them done. So P2O5 into 2 is what? P4O. Okay, so I'll draw the structure. Structure is important. Okay. She is on the one line is bisecting the other. This is in the front, this is in the back. See, it contains how many 6-member ring? These are all chair form. 1, 2, and this is the background. 3. So this is P4O6. How many sigma bond it has? Let me label it. 1, 2, 3, 4, 5, 6, 7, 8. Then 9, 10, 11. So it has 12 sigma bond. Okay. And in another one, so this is this, huh? No, one more will be there. See, then this. So whenever a double bond is there, first bond is sigma bond, second one is pi bond. Okay, so I'll draw it now again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry. 7, 8, 9, 10, 11, 12. So in this double bond, one bond is sigma. So let me write here 13, 14, 15, 16. That is 16 sigma bonds. And how many pi bonds? See here. Out of these two, one is pi. So 1, 2, 3, 4. So 4, 5. This is sometime asking. Finished?
Not yet, sir.
Okay, I'll give you 1 more minute. Let others finish. সেটা দেখলাম কড়াই মাঝি
Okay, done, sir.
Okay. So now we'll go for oxo acids of phosphorus. Now, what is the meaning of oxo acids? See, acids are of two types. One is that acid must have hydrogen. So hydrogen will be there along with that element. So these are called hydracids, where element and hydrogen is there. Example HF, HCl, HBr, HI, HCN. So in that case, those molecules do not contain oxygen. But what are the oxo acids? Oxo acids will have hydrogen, oxygen, and the element. Like HNO3, H2SO4, H3PO4. These are all oxo acids. Oxo acids of phosphorus. Okay, so I'll write here now formula and name. Okay, then I'll write structure. Then I'll write oxidation state of phosphorus. Then I'll write this basicity. Basicity means how many hydrogen it gives. This is 1. H3PO2. Name is hypophosphorus. Now, very interesting thing. You can draw any structure of phosphorus. What you will do? Any molecule. First, you don't look at the formula. First, you write phosphorus. Then put one oxygen, phosphorus oxygen double bond. And then write one OH. After that, look at the formula. See what is this? 3 hydrogen, 1 phosphorus, 2 oxygen. So out of 2 oxygen, we have already written 2. 1 hydrogen out of 3, we have written 2. So how many hydrogen you are left out? 2 hydrogen. What is the valency of hydrogen? 1. So what will be the structure? Right, finish. Oh yeah. Now I don't know whether you still remember how to find out oxidation state. See here. H3PO2. So what will write now here? It is 3A, A for this, B for this, C for this. We want to find out this. So you know sum of the oxidation number of all the elements in a neutral molecule is equal to 0. See here. Hydrogen is +1. Oxygen is -2. So it is 3 plus B minus 4 is equal to 0. It is B minus 1 is equal to 1. B minus 1 is equal to 0. Therefore, what is B? B is equal to plus. So right now here plus. So you want to write separately, not in this place. Write in another somewhere in other page. Okay. Now see. This oxygen hydrogen bond is highly polar. This is the one which will break to give you H plus. Phosphorus hydrogen bond is not polar. We have already seen that they do not form hydrogen bonding. This two hydrogen will not come out. Only it will give only one H plus ion. So this is it is 1. Oh. H3 PO3. This is called phosphorus. So again, I'll draw the formula. I'll write P. I'll put phosphorus oxygen double bond, and I'll put one. Okay. So out of 3 oxygen, 2 I have already written. I have 1 more oxygen and 2 more hydrogen. So what I'll write now here? Oxygen, hydrogen, because valence is 2. So 1. This is 2. So its oxidation state is 3. Now you know how to calculate how many oxygen hydrogen bond is there? 2. So basically it's H4 P2 O5. This is called pyrophosphorus. Don't get nervous. I'll explain you why the name is pyro. So I'll write 2 like this. So I'll do the same thing here. Okay. 2 phosphorus gone. Out of 5 oxygen, 4 you have already written. Out of 4 hydrogen, 2 have already written. Valence of oxygen is 2. So I'll write it like this. This is H and this is. Don't. I do understand why the name is pyro. Pyro, her name has come from Greek goddess of fire. We call it Pyrrhus. It is anything which you obtain by heating, or anything which you do by heating is called pyro. Okay. See, in your house, you might have some borosilicate glassware where you can even cook or you can make tea by putting just over the burner. These type of glasses are called Pyrex glass. Now, why the name has become pyro? See, interesting thing. Suppose I have taken, see, this one. I have taken 2 molecules and I heated it very strongly. What will happen now? See, 1 molecule of water goes up. And this oxygen gets linked to this phosphorus. Because see, otherwise it is, see, is it not 2 phosphorus acid? 2 phosphorus. When you heat it, loses a molecule of water to give you this molecule. So the name is called pyro. Oh. What is this oxidation state? His oxidation state is +3. Same, no? Plus. And how many hydrogen or OH group it has? 1, 2. It is, this is, it is 2. H4 P2 O6 is called hypophosphonic acid. Hypophosphonic. Anyway, this is a bit different. See here, it is not pyro, hypophosphonic acid. Hypo means always it is less. So there are 2 are there. I put it like this. I shall put it like this. I shall put it like this. I shall put it like this. All right. So now, out of 4 hydrogen, 2 I have written. Out of 6 oxygen, I have written 4. 2 P I have written. Now here I have to write here 1 OH and 1. Okay. But valence of phosphorus has to be 5. Here oxidation state is +4. And how many OH group? 4. So it is. This is the acid which you often use. It is called phosphoric acid. Sometimes you also call it orthophosphoric acid, but these are all old names. Phosphoric acid. So again you write here P, right? This. So out of 3 hydrogen, we have written 1. Out of 4 hydrogen, we have written 2. So this we have 2 oxygen and 2 hydrogen. No problem. Oxidation state +5. Basicity okay. Now 6. H4P2O7. This is called pyrophosphoric acid. Just like 2 phosphorus acid has joined together to give us pyrophosphorus acid. So we can also prepare pyrophosphoric acid by joining 2 molecules of phosphorus. So what will be the structure? This. Okay. See. Oxidation state plus 1, 2, 3, 4. Okay. Okay. Now we'll have a separate category of phosphorus, which are called polymeric phosphorus. Polymeric means where you join more than 2. Okay. So cyclo trimeta phosphoric acid. See, here also have the same thing. It's very easy to remember. So it is a cyclic trimer. It's a cyclic trimer. Okay? Yes. Oxidation state is +5, and here it is 3. Okay, now HPOCN. So it is a long polymer. See here, unit is this one. See, see HP1, 2, 3. HP1. So I'm going to draw the structure. N is there. Uh, this is the one. So this is called polyphosphoric. Polyphosphoric acid. Oxidation state is +5 and basicity is there. If n number of them are there, all of them are having one hydrogen. মুখ করে রাখলাম।
Done, sir.
Okay, just little bit. Let me put some ink in my pen. So now I'm going to give some important points of the acids. So note. One. In all the oxo acids of phosphorus, each phosphorus has one phosphorus oxygen bond. Phosphorus the double bond. And minimum one phosphorus oxygen. All right. So this is the structure. Is it there or not? Okay. Second, it is the OH bond attached to the phosphorus undergoes dissociation to liberate hydrogen, means acidic. The phosphorus hydrogen bond in oxo acids of phosphorus do not dissociate because these are less polar. Okay. Now, let us know. See here. H3PO2, it is hypophosphorus acid is monobasic. Yes, it has one polar with H3PO3 is dibasic. Why? As it has two polar with bond. This question comes. They justify the acidity. Then you draw and write down. Finish. was the last number I forgot? I think 4. Okay, put the number again. H3PO2, mind it, hypophosphorus. Is a reducing agent. Why? It is because it has 2 pH bonds. pH bonds are non-polar and on heating gives nascent hydrogen to carry out reduction. So I'll give you an example. H3PO2. Suppose you have reacted with silver chloride in presence of water. If you heat it, it will reduce silver chloride to silver. Then it will give you H3PO4 plus. No. Wait. ORAG. ORAG. See, is reducing. So I thought of taking half an hour more, but I think will it go a little bore? This portion is very big. I want to finish P block in this September month and D block also. Because I have to start organic. October I have to start. October, November, December, 3 months. I know I will not be able to finish, but whatever possible I have to finish. We started very late. Nah? It's not your fault, not my fault also, because your class 11 exam held and the result and everything came out very late. Anyway, so I'll go for now halides of phosphorus. So I'll go for PCl3 and PCl5. Okay. Phosphorus trichloride is called PCl. So it is being prepared by heating white phosphorus in presence of chlorine. For Cl3. Okay. So it is 6Cl2 if you heat it. Okay, you will get this one. But this is one. Second, it can also be prepared by heating white phosphorus with thionyl chloride, because till now you have no idea what is the formula of thionyl chloride. I am writing by spelling. So P4 8SO2Cl2, if you heat it, you get 4PCl3, 4S2Cl2. Don't get nervous. It is called sulfur monochloride. Sulfur mono plus carbon dioxide. Yes. Yes. Oh, sulfur dioxide, no written. What? It is a pale yellow colored valley liquid. This one you don't have to remember, but you only remember is the liquid. It fumes in, this is important for exam, fumes in moisture, because if the bottle is open, you'll find white fume is coming out. This for question for each time. It is because PCl3 reacts with water to liberate hydrogen chloride. Yeah, this is the one which. So right now here PCl3, PH2, H3, PO3. Okay, this is a liquid, and here you get the HCl. This is the one. So this is the one you have to write. Okay. Now reaction with alcohol. It reacts with alcohol to form halo alcohol. So don't get scared. HT and too much. PCl3, CrOH. This Cl replaces all this. So you'll get now here H3, CO3, 3R. So this is the, I write now here chloro. So with here chloro. Chloro. Okay. So let me write one specific example, because we are not familiar with R. So if I have taken Suppose I have taken here CH3, CH2H, ethanol. And if I react with PCl3, it will give me CH3, CH2Cl, H3, PO. You will get now here fluoro. Reaction with carboxylate acids. It reacts with carboxylic acids to form corresponding acid chloride. So I'll write now here. Okay, I'll write a specific example. Suppose I have taken here. What is this? This is called acetic acid or ethanoic acid. I react it with PCl3. So you will get here C, CH3, CO, Cl, H3, CO. Okay, this is called acid chloride. And name of this species is acetyl chloride. IUPAC name is ethanoyl chloride. See, this is the name of the family, and this is the individual. So now we'll go for structure. Structure is very easy because you have some idea about the VSCPR. So it is structure is this is the one, and this is the lone pair. But lone pair is not visible to us. So because of that, we call it pyramidal. Otherwise, it is tetrahedral. But as it is not visible, we call it pyramid. Now we'll go for PCl5 phosphorus penta. Okay, so how do you make it? So 1. Heating PCl3 with excess of chlorine. So now you can write here PCl3 plus Cl2. If you had, you get up here PCl. Second, heating white phosphorus with no with chlorine with excess of chlorine. So now we can write here now P4 formula of white phosphorus is P4. So I'll write now here 10 Cl2 3. So this is 4. Third, by heating white phosphorus with sulfuryl chloride. So don't get confused. See, thionyl chloride is SOCl2. Sulfuryl chloride is SO2Cl. PCl3 we use SOCl2, thionyl chloride. In phosphorus pentachloride we use sulfuryl. So we write here now P4 SO2Cl. It is going to give us 4 PCl5. How many chlorine we require? 20. So right now here 10. Okay, and if we heat it, you get here now 10. Okay. So please don't think I'm torturing you because generally I'm taking little less time for you people. I have a record of even teaching class for 4 hours also. So that way I think I have become too much affectionate for you people. But I'm doing it for your benefit. I can bet in none of the school, irrespective you are from APS, from MBOS or any other CBSE or ICSE school, nowhere they are going to teach inorganic property. Okay, properties. It is a white powder. The PCl3 is pale yellow oily liquid and it is a white powder. It fumes in moist air. This question is important for all books. So what will be the answer? It fumes in moist air because it reacts with water to liberate hydrogen. See, when you call hydrogen chloride means it is gaseous, and if it is water solution is called hydrochloride. Hydrogen chloride gas. So I'll write now here. Here I'm going to write in partial equation method. Then it's easy for you to balance. See here. PCl5. Then H2O. It will give you POCl3 plus 2HCl. This name of this one here, phosphorus oxychloride. Phosphorus oxychloride immediately reacts with water. POCl3 plus PH2O. It is H3PO4 and 3HCl. See, in PCl3, 3 chlorine, 3 water molecules. Here you have 5 chlorine. 5. See, ultimately how many molecules of water is taken? PCl5, 3 plus 1, 4. Because of that, I have done in partial equation method. In your book, they have not done. So for you, it is difficult to understand. Okay, so you get this one. What is this? So PCl3 gives you phosphorus acid and PCl5 gives you phosphoric acid. Remember, what is phosphoric acid you get. Okay, finish. I'll take 10 more minutes, I'll finish. Okay, now here we'll write. This reaction is used to produce heavy hydrogen chloride. Remember, heavy hydrogen chloride or deuterated hydrogen chloride. Remember, what is the meaning of this? See, heavier isotopes of hydrogen is deuterium by reaction with heavy water. You know the formula of heavy water? D2O. Now see here, I'll replace with D2O. So I will get here now DCl. Again, this too much hopeless. D2O. What will get now here? D3 DCl. Okay. Now see here. So you will get now here 4 D2O and 5 DCl. This is important again. So this is also known as heavy phosphoric acid or deuterated phosphoric acid. Okay. Now reaction with alcohol. Say I have taken here now. Sorry. This is the difference. In case of PCl3, 3 molecules of alcohol reacted. Here is only one molecule will react. So what you will get now here? You will get now RCl, POCl3, and 2HCl. So this is chloroalkane. This is what? Phosphorus oxychloride. So I'll write now here PCl5 and too much. CH3, CH2OH. So I'll get now here CH3, CH2Cl, POCl3, and 2. Now reaction with carboxylic acid. Okay, so I directly write like this. CCCO8 PCl5. See, 1:1. 1:1. And in case of PCl3, 1:3. So here you get, let's see. Oh. Now, important thing of PCl5 is this structure. Phosphorus pentachloride, both in gaseous and liquid state, is covalent and has trigonal bipyramidal. So it is see, this is the structure. So it's called trigonal bipyramidal structure. All the PCl3 bonds are not equivalent. See, these bonds are called equatorial. So it has 3 equatorial bonds. Okay. This is trigonal by 3 equatorial PCl bonds. This, and these are called axial. So to axial PCl the axial PCl bonds are little longer. These bonds are longer. This is due to the bond pair repulsion between PCl bonds. See, electrons are here. See, this is 90 degrees like this. So this pair of electron is 90 degree to this, and this is this. So to avoid the repulsion, it moves here. To avoid, not I could not say avoid, to reduce the bond pair repulsion, the PCl, the axial PCl bonds get little stretched. Just like this, suppose someone comes to hit us, we move away or duck because of this. So this is important for exam. In solid state, PCl5 is ionic and exists as PCl4 plus PCl6 minus. Where PCl4 plus is tetrahedral and PCl6 minus is octahedral. Please remember, this gaseous state and solid state is covalent and solid state is ionic. So let me draw it here, and with this now I will finish. See here. See, this is the structure is like this. Okay, so it is like this. So now this. So this is PCl4 plus, and this is PCl6. So this is tetrahedral at rest, and this is so bye.